Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from limits, right? And here we'll discuss the existence of this limit, that is limit x tends to 1, and here we have the function signum of x minus 1 divided by the greatest integer of x minus 1. So here we have to prove that whether this limit exists or not, right? So what we will do, we'll find the left hand limit of this function when x tends to 1 from the left of x is equal to 1, right? And similarly, we'll find out the right hand limit of this function when x tends to 1 from the right of x is equal to 1, right? So what we will do, we'll separately calculate the left hand limit and the right hand limit, right? And we'll see whether these two limits are finite and equal, right? So if these two limits exist and finite and are equal, then we can conclude that the limit of this function when x tends to 1 exists, right? So let us first find the left hand limit. So now in order to find out the left hand limit or the right hand limit, here we see that we have the function in the form of the quotient of the signum function and the greatest integer function, right? So what we will do, we have to take care of the signum function and the greatest integer function, and we will also utilize the definition of signum function and greatest integer function while evaluating the left hand limit or the right hand limit, right? So first we will find out the left hand limit, right? So the left hand limit can be written as the limit x tends to 1 minus, so this negative sign is the symbol for left hand limit. So limit x tends to 1 minus, and we have here a signum of x minus 1 divided by greatest integer of x minus 1, right? So now here let us substitute x is equal to 1 minus h, right? So when we take x is equal to 1 minus h, it means we are approaching towards x is equal to 1 from the left of x is equal to 1, right? And when we approach from the left of x is equal to 1, it implies that all the values which lies towards the left of x is equal to 1 are less than x is equal to 1, right? So x is equal to 1 minus h implies that 1 minus h is less than 1, right? So when 1 minus h is less than 1, we conclude that this quantity h is a positive quantity, right? So here h is a very small quantity, but it is a positive quantity, that is h is greater than 0, right? So when x tends to 1, then obviously h tends to 0, right? So now we will transform this limit in terms of h. So now we can write left hand limit as limit h tends to 0. For x tends to 1 minus, we can now have h tends to 0, because when x tends to 1, then here h tends to 0, right? And we have signum of, see here we have x minus 1, so we can write 1 minus h minus 1 divided by greatest integer of 1 minus h minus 1, right? Now we can solve this expression. So we have limit h tends to 0, and we have signum of see 1 and minus 1 get cancelled, so we are left with signum of minus h, and in the denominator again 1 and minus 1 get cancelled, so we are left with minus h, right? So now here we have a very interesting expression, right? Now in order to proceed further, we cannot directly substitute h is equal to 0, right? So in expression or we can say in expressions in which signum function or the greatest integer function or the fractional part function are involved, we must utilize the definition of signum function or the function greatest integer function will make use of the definition, right? So see, we know that the signum of x is given by positive 1 whenever x is greater than 0, right? So here we are writing the definition of signum function which will be utilized over here. So signum of x is equal to plus 1 for all x greater than 0, and signum of x is equal to 0 whenever x is equal to 0, and signum of x takes the value negative 1 when x is less than 0, right? And now let us compare this expression with this one, right? See, here we have minus h in place of x, and we know that h is greater than 0, right? So basically this quantity h, it lies between 0 and 1, right? And here we want to have the negative h, so what we will do, will multiply this inequality throughout by minus 1. So what we will get, we'll get 0, and when we multiply this inequality by minus 1, the direction of the inequalities get reversed. So we'll have minus h, here we'll have minus 1. So this can be rewritten as minus 1 less than minus h, and this is less than 0, right? So this is a very important inequality in limits which says that h minus h lies between minus 1 and 0, right? So here we have minus 1, here we have 0, so minus h lies between minus 1 and 0. Okay, so now from this expression we see that we have to find the value of greatest integer of minus h, right? So when minus h lies between minus 1 and 0, then by the definition of greatest integer function, the value of greatest integer of minus h must be equal to minus 1, right? Okay, because see, if we have say h is equal to 0.5, so here we have minus 0.5, right? Because h is greater than 0, so minus h is less than 0, right? So if we take h is equal to 0.5, then the value of greatest integer of minus 0.5 is equal to minus 1, right? So here we'll take minus 1 for greatest integer of minus h, right? Okay, now here we have signum of minus h, right? And minus h is less than 0 from this inequality, right? So signum of x will take the value minus 1 whenever x is less than 0, right? So it means signum of minus h should be equal to minus 1, right? Because h is a positive quantity and minus h is a negative quantity. So for negative quantities, signum of x takes the value minus 1. So signum of minus h is equal to minus 1, right? So now we can write limit h tends to 0 and signum of minus h is equal to minus 1, and greatest integer of minus h is minus 1. So here we do not have any term containing h, so we can omit this sign. So we have minus and minus get cancelled, so here we are left with 1, right? So the left hand limit of this function when x tends to 1 is equal to 1, right? So the left hand limit is equal to 1, and we see that this limit is finite, right? And we can say that the limit, the left hand limit exists in this case. Now let us see the right hand limit, whether it exists or not. So the symbol for right hand limit is RHL, that is which can be written as limit x tends to 1 plus. The positive sign shows that we are to calculate the right hand limit, right? So here we have signum of x minus 1, and in the denominator we have greatest integer of x minus 1, right? So again, in order to calculate this limit, we'll make use of this concept of h. So what we will do, we'll take x is equal to 1 plus h, right? So in this case we are taking x is equal to 1 plus h because to calculate the right hand limit, we have to approach towards x is equal to 1 from the right of x is equal to 1. So all the values which lies towards the right of x is equal to 1 are greater than 1, right? So x is equal to 1 plus h basically denotes the neighborhood of x is equal to 1, right? So now here again h is greater than 0, and we can now transform this limit in terms of h. So we have limit h tends to 0, and we have signum of, here we can take for x we can take 1 plus h, so we have 1 plus h minus 1, and in the denominator we have 1 plus h minus 1, right? So now we can make a simple simplification here. So 1 and 1 get cancelled, and we are left with signum of h divided by the greatest integer of h, right? And see, here again we have got an expression similar to this one, right? So now here also we cannot directly substitute h is equal to 0. Instead we have to make use of the definition of signum function and the greatest integer function, right? And see, h is greater than 0, right? So signum of h should be equal to 1, right? Because we know that signum of x takes the value plus 1 whenever this quantity, that is x, is greater than 0, right? So for all x which are positive or greater than 0, signum of x takes the value plus 1. So here we have signum of h, and we already know that this quantity h is greater than 0. So signum of h should be equal to 1, right? Okay, so now we have to now assign the value to greatest integer of h, right? So now we know that this h, it lies between 0 and 1, right? So see, here we have 0 and here we have 1. Now h lies between 0 and 1. So whenever h lies between 0 and 1, then by the definition of greatest integer function, the value of greatest integer of h should be equal to 0, right? So for example, if we take h is equal to 0.5, because 0.5 lies between 0 and 1, so the value of greatest integer of 0.5 is equal to 0. Similarly, we can take other values which lies between 0 and 1, and in all cases we'll get the greatest integer of h is equal to 0, right? So now the right hand limit, it becomes limit h tends to 0. Now signum of h is equal to 1, and the greatest integer of h is 0, so here we have 0, right? And now we can easily see that here we have an indeterminate form, right? So 1 over 0 is not defined, right? So we can write this symbol infinity. So the right hand limit of this function when x approaches towards 1, it does not exist, right? But the left hand limit is 1, right? So by the definition of existence of limits, we see that although left hand limit is finite and exists, but right hand limit does not exist. So we conclude that the limit of this function when x tends to 1 does not exist, right? So viewers, this is how we can solve these type of problems.